Good day everyone. For today, we will tackle about the quadratic functions. Imaginary numbers. We can find the square root of a negative number, but it is not a real number. If the value in the radicand is negative, the root is said to be an imaginary number. The imaginary number I is defined as the square root of negative 1. Square root negative 1 equals I. We can write the square root of any negative number as a multiple of I. Consider the square root of negative 25. Since the square root of 25 is 5, the square root of negative 25 is 5i. Complex numbers. A complex number is a number of the form a plus bi, where a is the real part of the complex number, bi is the imaginary part of the complex number. If b equals 0, then a plus bi is a real number. If a equals 0 and b is not equal to 0, the complex number is called an imaginary number. An imaginary number is an even root of a negative number, where 5 is a real part plus 2i is the imaginary part. Plotting complex numbers. How to represent a complex number on a complex plane. First, determine the real part and the imaginary part of the complex number. Second, move along the horizontal axis to show the real part of the number. Third, move parallel to the vertical axis to show the imaginary part of the number. And last, plot the point. In a complex plane, the horizontal is real, while the vertical is the imaginary.
Now, let's discuss how to add or subtract complex numbers. First, identify the real and imaginary parts of each number. Second, add or subtract the real parts. And the last one is add or subtract the imaginary parts. A plus bi plus c plus di is equals to a plus c plus b plus d multiplied by I. A plus bi minus c plus di is equals to a minus c plus b minus d multiplied by I.
And now, let's proceed to multiplying a complex number by a real number. First, distribute. Second, simplify. For example, 3 times 6 plus 2i equals 3 times 6 plus 3 times 2i, because 3 distributed to 6 and 2i. So 3 times 6 is 18 and 3 times 2i is 6i. And now, let's proceed to multiplying complex numbers together using either the distributive property or the FOIL method. We get a plus bi times c plus di equals to a times c plus a times di plus b times ci plus b times di squared, because I squared is equal to negative 1. A plus bi times c plus di is equal to a times c plus a times di plus b times ci minus bd. To simplify, we combine the real parts and we combine the imaginary parts. A plus bi times c plus di is equals to a times c minus b times d plus a times d plus b times c times I. And now, let's proceed to dividing complex numbers, where a is not equal to 0 and b is not equal to 0. Multiplying the numerator and denominator by the complex conjugate of the denominator. The complex conjugate of a complex number is a plus bi is a minus bi. Simplify, remembering that I squared is negative 1. And now, let's proceed to the characteristic of parabolas. Axis of symmetry. A line that divides an object into two equal halves. X-intercept. A line crosses the x-axis. Y-intercept. A line crosses the y-axis. Vertex. The highest point or top.
Now, let's discuss the equations of quadratic functions. The general form of a quadratic function presents the function in the form f of x is equals to ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. If a is greater than 0, the parabola opens upward. If a is less than 0, the parabola opens downward. The standard form of a quadratic function represents the function in the form f of x is equals to a times x minus h squared plus k, where h and k is the vertex. Because the vertex appears in the standard form of the quadratic function, this form is also known as the vertex form of a quadratic function. After knowing the equations of quadratic functions, let's now proceed or discuss the transformations of parabolas. First, shift up and down by changing the value of k. After that, shift left and right by changing the value of h. And the last one, stretch or compress by changing the value of a.
In addition with, let's proceed to how to find the y and x intercepts. First, evaluate f of 0 to find the y-intercept. Second, solve the quadratic equation f of x equals to 0 to find the x-intercepts. Finally, the quadratic formula and discriminants. The quadratic formula is the discriminant is defined as b squared minus 4ac. The discriminant shows whether the quadratic has real or complex roots. To sum up, analyzing quadratic functions. The vertex can be found from an equation representing a quadratic function. A quadratic function's minimum or maximum value is given by the y value of the vertex. The minimum or maximum value of a quadratic function can be used to determine the range of the function and to solve many kinds of real-world problems, including problems involving area and revenue. The vertex and the intercepts can be identified and interpreted to solve real-world problems. Lastly, some quadratic functions have complex roots, meaning that they do not cross the x-axis.